In this video, we shall discuss when does a function become maximum and when does a function become minimum. We call it as maxima and minima of a function. First of all, before we start this, let's understand how the curve looks like and what happens at a maximum point, what happens at a minimum point. So imagine this is the x and y axis, and let's draw a curve. Let's say the curve is like this. You can notice that as the x value changes, the corresponding y value keeps on changing. So I am just putting some range of values here so that we can understand. Let's say when x coordinate is 1, y coordinate is 4. When x coordinate is 2, y coordinate is 6. When x coordinate is 3, y coordinate is 10. When x coordinate is 4, y coordinate is 7. X coordinate is 5, y coordinate is 4, etc. And when x is 6, let's say y coordinate is 2. And when x is 7, y coordinate is 3. So we have just plotted the points on the curve so that to get an idea. Y's values are 4, 6, go on increasing, then it reaches 10, then decreases, comes to 7, 5, then 2, then again increases. We have noticed that at this point, the y is getting maximum when if you count only from 1 to 5 or 1 to 7. When x coordinate is between 1 to 7, x values are between 1 to 7, y will attain maximum at 10 and maximum value will be 10 and minimum value will be 2. Maximum is obtained at x is 3. Minimum is obtained at x equal to 6. So we say this function is maximum at x equal to 3 and maximum value is 10. And minimum at x equal to 6 and the minimum value is 2. So this is the meaning of maxima and minima. Remember, it is not absolute maxima. Within this stipulated area, within this local area, this is the maximum point and this is minimum point. So we call them as local maxima and local minima. So whatever I am going to explain to you today is only about local maxima and local minima. What is the speciality of a local maxima? If I draw a tangent at this point and if I draw a tangent at this point, what have we noticed speciality of this tangent? It is parallel to x-axis. So the slope of this tangent will be 0. Slope of the tangent this also will be 0. No other place the slope will be 0. So maximum point basically means it is a peak point and this is the bottom valley. This is like a hill and this is the top of the hill and this is the bottom of the valley. That means the maximum point and minimum point are only the 2 points where the slope of the tangent will be 0. All other points, slope of the tangent may be either positive or maybe negative. So we can say at the maximum point and the minimum point, the derivative will be 0. The derivative will be 0. So the first point to remember in local maxima and local minima is the derivative of the function at that point will be 0. Second point to remember is if I draw a tangent like this, the angle theta is acute. So the slope of the tangent here will be tan theta is acute means theta is in first quadrant. Theta is in first quadrant, tan theta is positive. So slope will be positive. If you take a point after the maximum point, the tangent that will be made will be obtuse. So the slope of the tangent here will be negative. So at a maximum point, at a local maximum point, slope changes from positive to negative. That means the slope is decreasing. So I can say rate of change of slope. Rate of change of slope. That means the second derivative is derivative. That means the second derivative will be negative at a maximum point. Why second derivative will be negative at a maximum point? Because the slope changes from positive to negative. As the x coordinate varies, here slope is positive, it will become more and more near to 0, then it becomes slope becomes 0 here, then slope will become negative here. Slope changes from positive to negative means slope is decreasing. So rate of change of slope will be negative. So this is a point to remember. In a maximum point, Slope of the tangent will be 0, which means derivative is 0. Rate of change of slope will be negative. That means second derivative will be negative at a maximum point. At a minimum point, what will happen? The slope will change from negative to positive. Slope changes from negative to positive. So the rate of change of slope will be positive here. So the second derivative will be positive here. So this is the 2 points to remember. First point, the slope of the tangent or derivative at the maximum and minimum point will be 0. Second derivative will be negative at maximum point, and second derivative will be positive at the minimum point. Let us analyze this in another way. One method I already spoke to you. Now second method. I am only taking now the maximum point. Let's not take the minimum point, only maximum point. Let's say this maximum is obtained at x equal to a. That means this point is a comma f of a, because the function is f of x. When x is a, y will be f of a. So this point P will be having coordinate a comma f of a. Let's have a look at the point just before a, which we denote as a minus h. And also let's have a look at a plus h. That means x coordinate of these 2 points. The x coordinate of this point is a minus h. X coordinate of this point is a plus h. If I draw a tangent here, this angle is theta. Theta is acute. So slope will be positive. So tan theta will be positive here. What do you mean by tan theta? It is the slope. F dash of a minus h will be positive. Just after the point, if I draw a tangent here, this is obtuse angle. So tan theta will be negative here. So f dash of a plus h will be negative. So this is the second method of calculating a maximum point. The derivative at a will be 0. This derivative at a minus h will be positive, and derivative at a plus h will be negative. This is also one of the methods to recognize the local maxima, and local minima will be reverse of it. We'll see what happens in case of local minima. In local minima, the graph will be in this manner. Let's call this point as B. Let's take this point as B minus h and this point as B plus h. So naturally the derivative at f dash of B will be 0 because slope is 0 there. If you take here, it is obtuse angle. Therefore f dash of B minus h will be negative. If you take a point here, draw the tangent, it's acute angle. So f dash of B plus h will be positive. So at a minimum point, what are the conditions satisfied? F dash of B 0, f dash of B minus h will be positive, f dash of B plus h will be negative. This is the second method. But most of the problem, I am going to use the first condition which is given. What is the first condition? F dash of B will be 0, f double dash of B will be positive in case of a minimum point. In case of a maximum point, f dash of A will be 0 and f double dash of A will be less than 0 for a maximum point. So x equal to A is a maximum point, this is x equal to B is a minimum point, these things happens. So this is what we are going to apply. Let's see how we do this as in a problem. Let us try to solve a problem. Examine the function, this function for maxima and minima. So I am basically going to teach you the procedure for finding maxima minima of a function. Basically we are doing local maxima and local minima. Although it's written maxima and minima, it means local maxima and local minima. So the first point that we must do is, we know that the derivative at the maximum and minimum point is 0. So step number 1 is find f dash x, find the derivative and equate f dash x to 0. That's your first step. After equating f dash x to 0, you will get the value of x. And those values of x are the point where the function becomes either maximum or minimum. Then we will recognize which is maximum, which is minimum. So I'm going to start with f dash of x. So f dash of x is derivative of x cube, 3x square, 18x and 24. So I got the derivative. I can see there are multiple of 3. So let me take a 3 common. Wherever it is possible, we'll take common. Now I'll equate f dash x to 0. So equating f dash x to 0. That is 3 times x square minus 6x plus 8 should be equated to 0. So that is x square minus 6x plus 8 is 0. That is x minus 4 into x minus 2 equal to 0. Product is 4 into 2, sum is minus 6. So that means x is 4 and x equal to 2 are the roots. So my conclusion is f dash of 4 is 0 and f dash of 2 is 0. This is my conclusion from here. That means x equal to 4 and x equal to 2 are the local maxima or local minima. One of them is local maxima, one of them is local minima. Now I go for the second step. Second step, step number 2. I find the second derivative and find the value of f double dash of 4 and f double dash of 2. The value of f double dash of 4 and f double dash of 2 will decide whether it is a maximum point or a minimum point. So f double dash of x value is, first of all, find the second derivative, 6x minus 18. So f double dash of 2 will be 6 into 2 minus 18, which is minus 6. 12 minus 18. F double dash of 4 would be 6 into 4 minus 18, which is plus 6. One which gives you negative is the maximum point. That means x equal to 2 is the maximum point. One which gives you positive will be the minimum point. So the function is having maximum at x equal to 2 and minimum at x equal to 4. So one which gives you negative will be a maximum point and one which gives you positive will be given a minimum point. So my conclusion is this function f of x is maximum, has a local maximum at x equal to 2 and a local minimum at x equal to 4. We come to step number 3. Step number 3, first of all, let me make the conclusion. So I have not written the conclusion here. So first conclusion is f of x is maximum at x equal to 2 and minimum at x equal to 4. This is my conclusion from the step number 2. Step number 3, we are going to find out what is the maximum value. So maximum value of the function, that means whatever the y coordinate at the maximum point. Maximum point is 2. Y coordinate at maximum point is obtained by substituting in the function. That is f of 2. That is 2 cube minus 9 into 2 square plus 24 into 2. That gives you 8 minus 4 3 36 plus 48, which gives you 20. And minimum value is at 4. So that is f of 4. That is 4 cube minus 9 into 4 square plus 24 into 4, which gives you 64 minus 16 into 9, 144 plus 96. And which will give me 16 as answer. So my conclusion is f of x is maximum at x equal to 2 and the maximum value is 20. Minimum at x equal to 4 and the minimum value is 16. Let us sketch this as a function and see how it works. When I plot this as a graph, it will be like this. Maximum at 2, minimum at 4. 2's x coordinate is 20. 4's x coordinate is 16. So if I draw the graph will be like this. So we can say this point is the local maximum and this point is the local minimum. So let me make it a little more steeper so that we can understand better. So this is a minimum point and this is a maximum point. But remember, there are still minimum here. You can have the when x is 0. When x is 0, y coordinate is 0. In fact, it is passing through the origin. So 16 is not the minimum value. Even 0 is less than 16. But what we are talking about is only the local maximum, local minimum. That means within this stipulated region, this is a minimum and this is a maximum. So within a local domain, the function attains maximum at 2 and minimum at 4. And this is called local maximum, local minimum. But otherwise we call it as absolute maximum, absolute minima, which we are not interested at this moment. So at this moment we are interested only at where the function attains the peak value and where the function attains the bottom value within a particular domain. Let's practice one more problem. So we need to find maximum minima of this function. So first step is to find f dash of x. Step number 1 is to find f dash of x. That is 6x square minus 42x plus 36. 42x plus 36. 6 is the common factor. So x square minus, so 7x plus 6. So this can be factorized as x minus 6 into x minus 1. Which means f dash of 6 is 0. Or we'll do one thing, we'll equate f dash x to 0. So equate f dash x to 0. That is x equal to 6. X minus 6 into x minus 1 is equal to 0. So x equal to 6 and x equal to 1. So f of x has either local maximum or local minima at 1 and 6. Now what we do, we find out which is local maximum and which is local minimum, for which we calculate f double dash x. F double dash x is derivative of this. So 12x minus 42. So I can write that 6 if I take common, it will become 2x minus 7. Now I'll calculate f double dash of 6. 6 into 2 into 6 minus 7. That is 12 minus 7, that is 30, which is positive. F double dash of 1, 6 into 2 minus 7, that is minus 30, less than 0. So what have we learned? The one which gives second derivative negative is the maximum point. The negative is obtained at 1. So f of x has a local maxima at x equal to 1 and a local minima at x equal to 6. Now we need to calculate what is the maximum value at that point and what the minimum value. So maximum value of the function. So I'll write like this, max f max is equal to maximum at x equal to 1. So substitute x as 1 in it. So 2 into 1 cube minus 21 into 1 square, 36 into 1 minus 20. Very important. Do not get confused that this is a maximum value. Second derivative's value only decides whether it is positive or negative. The value of the function is the one which gives you maximum value, because maximum value means what? The value of the y coordinate. Y coordinate is obtained by the function's value. So we will get the answer as 2 minus 21. So positive is 38. 38 minus 41. That gives you minus 3. Now f minima, that is 2 into at 6, 2 6 cube minus 21 6 square, 36 into 6 minus 20. That will give me answer 6 cube is 216. So 512. We'll take a 36 common. So this becomes 12. This becomes 21. And this becomes 6 minus 20. So that gives me 36 into. So 18 minus 3 minus 20. That gives you 308. So 108 minus 20. So minus 128. So I can say the function f of x is minimum at 6 and minimum value is minus 128. Maximum at 1 and the maximum value is minus 3. In this problem, we need to show that the function f of x is maximum at x equal to e. So we will prove that first derivative at e is 0 and second derivative at e is negative. If you prove this, we have shown that it is a local maximum point. So first we'll calculate the derivative. F dash of x is derivative of log x upon x. So x into derivative of log x minus log x into derivative of x upon x square. So 1 minus log x upon x square. This is the f dash of x. Then I'll also calculate f dash of e. So 1 minus log e upon e square. 1 minus 1 upon e square, which is 0. So the derivative at x equal to e is 0. Now I'll find the second derivative at x. Second derivative is d by dx of 1 minus log x upon x square. So I start from x square into derivative of the numerator minus numerator into derivative of the denominator upon square of the denominator. So that gives me minus x minus 2x minus minus, so plus 2x log x upon x raised to 4. So that is x, if I take common, minus 3 plus 2 log x upon x raised to 4. Now I'm going to find out the second derivative's value at e. That gives me e into minus 3 plus 2 log e is 1 and e raised to 4. So it is minus 1 upon e cube, which is a negative number. So what have we proved? First derivative at e is 0, second derivative is negative, so my conclusion is f of x is maximum at x equal to e. Therefore, f dash of e is 0, f double dash of e is less than 0, so f of x has a local maxima at x equal to e, as a local maxima at x equal to e. That is my conclusion.